Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera. Today we need to understand the concept of escape velocity. So definition of escape velocity is minimum velocity required by a body on the surface of Earth to completely escape from the gravitational pull of Earth. So this means for the escape velocity is the minimum velocity required by a body on the surface of Earth to completely escape from the gravitational pull of Earth. Okay, so we continue. So here is the Earth, and then M is the mass of Earth, R is the radius of Earth, and then here is the body. In this case is the rocket, maybe a rocket, and then the rocket with the mass M kilogram. Okay, so before we continue, so we have to first we knew that the gravitational potential energy at the Earth's surface we take as a U naught. Then because gravitational potential energy, so the unit is a joule. And then we consider the gravitational potential energy at infinity. So U at infinity actually is we take as a equal to the 0 joule. Then the rocket start from the Earth's surface, and then the rocket is moving, travels to the infinity. And then we have the gravitational potential energy at Earth's surface, U naught, we can write as a here, negative Gm m over r. And then for the gravitational potential energy at infinity is equal to 0, so we write as a U infinity is equal to 0. Okay, so from the conservation of energy COE on the body, so in this case the body actually is a rocket. So the kinetic energy supply and then the change to the gravitational potential energy, that is a conservation of energy, changing from the kinetic energy, the change to the gravitational potential energy. Okay, so in this case for the kinetic energy we have the half mv. E is the escape velocity, power of 2, is equal to the change in the gravitational potential energy. That's mean for and U final minus the U initial, because the gravitational potential energy at the infinity is 0, minus the half Gmm over the r. M is the mass of Earth, m small m is the mass of the body or the rocket. Then we continue, so we have this equation, then we manipulate this equation, then we can get the escape velocity VE is equal to the surd 2gm over r. So before we continue, so I just to refer here. So at Earth's surface here, at the Earth's surface, so that means the weight of the, actually it's not the satellite, the weight of the rocket, W is equal to the gravitational force. And then at the Earth's surface, so that means weight of the rocket or the body is equals to the mg equals to the gravitational force G m over the r power of 2. Therefore we can write this equation, G r power of 2 equals to the Gm. So we cancel with the mass of the rocket, so we can get this equation. So and then we have the gr power of 2 equals to the gm. We replacing here, then we can write this equation as 2 gr equals to the set 2 gr. Then we continue, also we can write as 2, so gr is gr power of 2 is equal to the gm, and then over the r. So also we can write as this equation. Okay, so now we can get the escape velocity. We can calculate the escape velocity by applying this equation, or we can get also the escape velocity by using this equation. So before I stop, just to recall the idea how to get the escape velocity, actually from the conservation of energy on the body. That's mean change from the kinetic energy to the gravitational potential energy. Then we manipulate all the equation, and then we can get the escape velocity is equal to the set 2 gm over r, or we can get from the set 2 gr. R is the radius of Earth, g is the gravitational acceleration, g is the gravitational constant, m is the mass of Earth. For that, thank you.